Okay, this is the Fusion 360 tutorial for the 11A part. So part 11 is a piston, a rod, and a link. So this is the piston portion. So let's open our model 11A. Should look something like this. There was a little bit of debate on the wall thickness because the drawing didn't fully define that diameter, but it should look close to this. Now again, this is going to be a 100% turn part. So again, you're going to need some geometry from your sketch that you made this from. So you should have revolved the outside portion of this, and you should have a sketch that looks somewhat like this U-shaped profile. Now some people might have included the hole. I chose to put the hole in as a separate feature. It should work either way, but when we get into the machining side, we need that profile. Alright, so now we're going to change our mode from design to manufacture, and we're going to go to the turning tab. Your icon should look like this after you've done that. We're going to create a setup. It's just going to be called setup 1, and we need to change our operation type to turning or mill turn. Now, a mill turn can do both milling and turning. The stock defaults are going to change when you switch to that. So you notice the Z-axis is now pointing in line with the part. If yours isn't, you'll need to manipulate it so that it looks like pretty much what is shown, but I need to flip the X-axis, and we should have the Z-axis pointing in the same orientation as the spindle, which would go in line with the cylinder. So if you have nothing here and you don't have the body selected, you need to select the model as the body for the setup. Different than a lathe is held in a chuck. So our chuck reference is from the back of the model, which would be here. How far back is our chuck? And so we're going to have 0.4 or 400 thousandths of exposed material to give us clearance for our tools and move around. That's quite a bit, but that's okay. And we're going to go to the stock tab. We're going to do a relative size cylinder, and our diameter is pretty close to a ½ inch. It's 12 millimeters. 12.7 is a ½ inch. So what we want to do is come up with a radial stock offset that gives us a ½ inch here, because otherwise we're going to have to step up to the next size material. Okay, so let's put in 12 thousandths, round up to the nearest 5, and that gives us a ½ inch diameter on our diameter. Now on our length, on the front side of the stock, we're going to put 30 thousandths. Oops, not 300, not 30 inches. We're going to put 30 thousandths of extra material on the front, and on the back side, we're going to put a whole inch. So we have an inch to hold on to, but 0.6 of it will be in the chuck, and 0.4 of it will project out of the chuck. Now we're going to go to post-process, and this is part number 11A, so we're going to call that 11, and we had 3 programs to cut 11C. Let's call this 1109, and then our program comment will be 11A op1 lathe, and then we're going to have work coordinate system 1. Now we can hit OK on this, and we zoom out. So this is our stock. Now, if we were cutting a whole bunch of these, we'd probably have a 3-foot bar, and this would just be a minimum to cut with as the bar gets shorter. And we have our extra material on the front face. Alright, so let's turn this down. Generally you start off with a facing. That's kind of like a face mill equivalent on a mill. So we're going to go to face, and we're going to select from the Rocket Tool library, which you should have already downloaded. We're going to use the first tool in the library, tool number 1, and it's going to come in at an angle and face and go to the center by default. We're going to leave all the default feeds and speeds. Again, it's going to try to maintain a surface footage with the tool with a maximum RPM of 500 RPM, and then our chip load is 0.008. Okay, we're going to go to the geometry, and it's just the model front. If we wanted to leave extra material for another cutter to remove, we could do that. Now we're going to go to clearances. We have cylinders instead of planes because this is round. And we're going to leave everything at default except for we're going to come down and we're going to put in a distance cut below inner radius. So we go from the cyan to the inner radius right now, which is set at 0. We're going to go a little bit farther just to make sure our cutter faces off all the material and doesn't leave a little dimple in the middle. Okay, so the distance to cut below inner radius is going to be 10 thousandths. We're going to go to passes. We're going to leave this all at default. We're taking off 30 thousandths. We could do multiple passes, so let's do that, and we're going to have a step over of 0.02, and we're going to do a finish pass. We're going to do one of them, and our step over will be, we'll say 5 thousandths, and our finish feed rate we'll leave at default. Now this repeat finish pass would do just another one right at the finish number, and you would do that for if you have a situation where you have vibration and you think the part itself is deflecting. In the next tab, we're going to leave everything at default and hit OK. So we have a 45-degree lead in, and then we feed into the part, and then we cut past Z0 to make sure that's fully cleaned up. If you end up with a little dimple there, if you come through the drill here, the drill will not cut on center. Alright, so now we've faced that. Now we're going to cut the outside diameter. For that, we're going to use the same exact tool. It's not skimming a whole lot of material off. But we're going to use a different command. In this case, I don't believe we need to use a roughing. So we're just going to go straight to finish because we're removing so little material. We're going to stay with tool 1. We're going to leave everything at default. We'll move on to geometry. You want to select this model box, and we are going to select profiles. Now we can't pick on the silhouette, so here's where we have to go over to the browser, and we need to maximize models, maximize the model, and then we're going to maximize the sketches, and we're going to make the sketch that we originally revolved the part visible so that we can select on the silhouette. There's other methods to derive at this. You could project a sketch, but if you revolved your part, it should be fine. Alright, so we can go ahead and collapse that down now, and we're going to go over to the model contour, and we're going to select the sketch. Alright, so model front is the front of the model, and we would want to do a tangential extension of 0.01, so 10 thousandths. So it's actually going to extend where we're cutting 10 thousandths past the work. That way we're sure that we're engaging before it cuts material. It's wrapping and feeding in. On the back side, we want to cut past because we're going to come in with a parting tool that's 118 thousandths wide. So we want to overcut the diameter so that that parting tool doesn't have to do any roughing. So we're going to go a tangential extension on there of 0.125, which is 1/8 of an inch. So that should overshoot a little bit. Then we're going to go with radiuses. This is where we set the diameters of parameters. So we're starting at the stock diameter, and then we're going to go to this inner diameter. What we're actually going to machine is just this diameter here. So we're going to change it from stock ID, and in this case we could go with model OD, and that'll get the largest diameter. Okay, we're going to go to passes. We're going to leave all this at default. We're taking off so little, I don't think we have to do much. And linking, we're going to leave all this at default except for our linear lead-in is going to be at 0. We're going to come in at the same angle as our cut in this case. And we don't want to lead out. And we'll select OK. And then we get a straight cut that just goes across and cuts the outside of the part. So we started 10 thousandths out extra and went an extra 1/8 after. All right, now we have the groove to do. We're going to use this single groove. Now, our slot is 3 millimeters. So 3 divided by 25.4 gives us 0.118. So basically, our default grooving tool is already at that width. So if we put the grooving tool right on center, it should make the correct size cut there. Is the grooving tool that we have, is one of them in the library, is already at 118 thousandths. Okay, so we're going to use the single groove tool. We're going to go select tool number 4 from the Rocket tool library. Okay, it's a grooving tool, and it has a carbide insert, and it's called square, but it does have a very small radius here. It's I believe 4/10 or 4 thousandths. Okay, so we're going to leave all this at default. We're going to go to geometry, and we're going to select our profile, and it's going to default to having the cutter on the middle of what we selected. Okay, and we're going to go to our stocks. Okay, so our outside diameter is going to be, our clearance is going to be from the model OD because we've already turned it down. Our retract clearance and our outer radius is also going to be at model OD. And now our selected contour is what we selected. Go to passes. We're going to leave this all at default. Linking, we're going to leave all that at default and hit OK. Our next operation is going to drill this hole. We're going to go to drilling. And we're going to select a tool. We're going to go to the TCOSE library. And we're going to select tool number 13, which is our 4 millimeter drill. And we're going to select OK. Now there's one thing we need to do. This tool was made for a milling library, and in the lathe, if it's on center line, the tool's not spinning. So we need to go back and select it from the document that you're working within. Don't change the one on your main library, because then if you use it for milling, it won't give the code to turn the spindle on. And so within the document library, once you've selected the tool, you should be able to go to Edit Tool. And you go to this last tab that says Post Processor. And you deselect the box that says Live Tool. And that just makes sure that the lathe doesn't receive a code to turn the spindle on that the tools are associated with, especially if the lathe isn't capable of live tooling. Okay, we're going to hit OK, and OK again. Okay, so we've selected our tool, and now we're going to go to Geometry, and we're going to select the hole in the center of the part. And there's only one hole, and now we can go on to the next tab. Now it works the same way as the drilling cycle on a mill. You have your planes relative to the drill bit. Okay, we're going to change that to model top, which is actually the face. It's a little confusing. And our drilled height will be from the top of the hole to the bottom of the hole, but we want to break through, and we want to go an extra 0.1. That makes sure that we'll have drilled all the way through. Now when we face down the next one, it'll already have a hole spotted there for when you face it, and it'll help self-center the next drill on the next part when you advance the bar. We're going to use a deep drilling cycle again, and our peck depth, we're going to set it at 0.03 for this diameter, and we'll call that done. Now we're going to come back and we're going to part this tool off. Now I just realized I've made a mistake, but we'll be able to recover from it pretty quick. I used the grooving tool, then I drilled, and then I'm going to come back and use that same grooving tool. So let's move the grooving tool down in sequence, and the drill will pop up. It'll also give more mass to dissipate heat, because this won't be cut. The drill will be cut first, then the slot will be cut. And it'll give more mass to the part to dissipate the heat of the drill bit, which can generate quite a bit because coolant, unless you have coolant through the tool, coolant doesn't get down in the drill bit on a lathe too well. Alright, so we got our single groove. Now we're going to do our parting. It's this icon here, turn parting. Alright, it's going to automatically assume the back of the part. And we got flood coolant. We're using tool number 4 again. Now we're going to leave all this stuff at default. Now we're going to go to geometry. It's model back. We can leave that alone. We can go to radii. We do want to leave the clearance on stock OD because we do have a mass of stock to the left or the back of the part. We're going to change our outer radius to model OD, so it'll start feeding there. And our inner radius is going to be 0. Now, we don't really have to go past because there's a hole in the center of this. So we could select the stock ID. We could select it. We go to selection, and we could select the hole diameter. And that way it only faces between the cyan and the blue. Now, if our drill runs a little undersized, we're going to get some flash there. So we do want to extend a little bit beyond. So let's go 0.01. So it'll give us 10 thousandths beyond this dark blue, but we're not going to go all the way to the center of the part. This part will then fall off, and we'll need to make sure we have a parts catcher underneath it. Alright, we're going to go to passes. We're going to leave all this at default. Then we'll go to linking and leave this all at default. We'll hit OK. Now let's simulate what we've done so far so you help you visualize what you've done. And we're going to highlight the setup, which shows the stock, and we're going to press simulate. Make sure you have the box checked to show the stock, and then we're going to hit play. So we did 2 passes, 3 passes the face. We roughed out, or we finished outside. Our drill bit comes in and drills a hole in the center of the part. We come in and do our single groove, and then we come in and do our parting move. which looks like it left kind of this weird dish boss feature there, which is fine. It's all going to get machined off. So that's it for this part. You'll need to upload one setup sheet and one program to complete the assignment in Canvas. You need to upload those in Canvas. And thanks for listening, and we'll catch you on the next one.